Thanks for coming. My name is Hannes, and I work for a company called Fine Software, and we're about making one of the fastest growing apps in the marketplace named JXL. And before starting JXL, I actually worked for Atlassian for a couple of years in the beautiful Sydney headquarters. And even before that, I was working on another app called Portfolio for Jira. As some of you folks may know, Portfolio has been acquired by Atlassian and has now evolved into advanced roadmaps. And this acquisition was actually announced pretty much right here at Team, what was it, 2014 or Summit 2014, so it's good to be back. As you can imagine, throughout the years, I've been part of countless teams. And I think there's only one thing that all of these teams have in common, and that is that every team is different. Every team has their own ways of working, their particular requirements. And I firmly believe that it is our responsibility as Atlassian experts, as administrators, as managers, to provide our teams not just with a Jira, but with the best Jira for each and every one of our teams. And luckily, we have quite a few tools for that in our tool belt. Right? We have the different project types. We can create a company-managed software project for the one team. We can create a team-managed business project for the other team, or we can push it a step further and add a custom issue type, or even create a completely custom workflow for them. But by far the strongest tool that we have, and I think a major part of Atlassian's success story, is Jira's extensibility. You folks are all familiar with the marketplace. There are there's countless of very well done, very well engineered apps on the marketplace. And I would always recommend to first check the marketplace whenever a new requirement arises. But if, sorry for that. But if, and that's a big if, we do not find what we need in the marketplace, we can push it yet another step further and extend Jira ourselves, build our own Jira app. And that's what we're going to do today. And we're going to do it with Forge, which, as you know, is Jira's latest and most powerful extensibility system. But before we get into it, I think it's important to understand how Forge came to be and how it relates to the other systems that became Forge. So join me for a brief history of extending Jira. The first system that I would like to talk about is P2. When I built Portfolio for Jira almost 10 years ago, it was based on P2. P2 stands, believe it or not, for Plugin System version 2. Yes, there's also a Plugin System version 1, but that's not relevant anymore, so we're going to skip that. But P2 is still very much relevant because it continues to be the plugin system for data center. Now, how does P2 work from a developer's perspective? As a developer, you're writing your code, typically in Java, and you may also write some static front-end assets like HTML and JavaScript and CSS. And then you bundle all of these together into a so-called artifact. And this artifact you can then install into Jira. Right? Your app runs as part of the Jira executable on Jira's server, on Jira's database, using the same CPU, the same memory. And that's really, really convenient, right? Because yes, we still need to write good code, but we don't have to worry about the operations. We obviously already have a server. We obviously already have a database because otherwise we wouldn't have a Jira. So this model is really, really good and still used in data center, and they're fantastic apps built based on P2. P2 only really started to cause some headache when Atlassian took the leap into the cloud. Because it's one thing to have a piece of code that you selected from the marketplace or that you wrote yourself run on your Jira server. But it's a very different thing to have such a piece of code run on a shared cloud infrastructure that in one way or the other is shared across millions of users. And this is how Connect came to be, Atlassian's first extension system for the cloud. And what Connect does is it moves your application outside of Jira onto its own cloud infrastructure. From there, it can then call defined REST endpoints and API endpoints. And similarly, on the front end, code now runs in iframe-based sandboxes, but still continues to do calls to your own backend and, of course, also to the Jira endpoints. And now this is a very straightforward architecture, right? It works very well, and again, there have been fantastic apps being built on Connect. There's a tricky part to it, though, and that tricky part lies in the operations. If you look at the two cloud infrastructures, well, one is the Atlassian cloud, right? And that's fine. That's operated by Atlassian. We don't have to worry about it. But the other infrastructure, that needs to be operated by the app developer. And if the app developer is you, then you need to operate that cloud infrastructure. And that's hard, right? Yes, we have AWS, we have Google Cloud, etc. But there's still plenty of things that you can do wrong, and it's legitimately hard. Now, if you do a app business like we do, it's fine. It's part of the job. But if you're an administrator that has thousands of other things on their plate, this is a real obstacle, a real hurdle. And this is where Forge comes in, because what Forge is doing is that it removes the need for your own cloud infrastructure, and it lets you deploy your application into the Atlassian cloud. Now, why is that possible now and wasn't possible a couple of years ago when we came up with Connect? It's because cloud computing massively evolved over the last couple of years, and we now have mechanisms and patterns that allow us to sandbox pieces of code in a secure way. And then you still, other things didn't really change that much, right? You can still talk to Jira via defined endpoints. Your front end can still talk to your own endpoints and also to the Jira endpoints. But the operational part is huge, right? We don't have to worry about operations anymore. The only thing that we still have to worry about is writing good web apps. Luckily, there have been massive developments in the last couple of years, often kind of talked about under the headline or buzzword, if you want, of a jam stack. And the jam in Jamstack stands for JavaScript, APIs, and markup. But that can mean everything and nothing. So let's look into the concrete architecture and maybe compare it with a traditional web architecture. And the traditional web architecture is a very layered thing, right? Like there's a request that originates from the browser, it goes to the web server, it goes to an application server. Within the application server, you do all your kind of database queries and whatnot. You generate some HTML. The HTML needs to go back to the web server and back to the browser. Not necessarily rocket science, but there's still a lot of things that can go wrong. If you compare that to the Jamstack architecture, it's much simpler. There's really only two parts. The first part is a so-called content delivery network that hosts all your application's static front-end assets. And these assets are the same for every user. They don't contain any sensitive material. They can be shared across everyone. They can be public, which allows CDNs to be highly optimized. So you can load these resources very, very, very quickly. And once you loaded them, and the browser is executing your web app can make asynchronous calls to APIs and load whatever data you're interested in. And that's very, very simple, especially when the APIs already exist. So this thing is fast, secure, and very, very easy to do. Now, how does that relate to Forge? Well, interestingly, a Forge application can also be split into two parts. We have what in Forge is called a resolver, which is basically a set of endpoints. And on the other hand, we have static resources, which in a true Jamstack style are deployed onto a CDN, onto the Atlassian CDN. What now happens is that your static resources are downloaded in the browser executes your static resources, and you can make asynchronous calls either to your own endpoints or to Jira endpoints. And as these Jira endpoints are very, very powerful, often enough, you really only want to call the Jira endpoints. You don't need your own endpoints at all. So on that note, let's look at the simplest possible Forge app. Let's call it Hello Forge. And Hello Forge really only contains of two files. We have the app descriptor, which is generated by the Forge CLI, and we have a static front-end app. Very simple. We'll get back to that later. First, have a look at the app descriptor, and there are a couple of things in there. We have an app ID, which is generated by the Forge CLI for us. We don't have to worry about it. And then we have a number of modules. In this case, we have a project page, which adds an additional entry to the project sidebar within a project. We give it a title, and most importantly, through a little bit of redirection, we're pointing that module to the static front-end resources, which in this case is just a plain HTML file that says hello. Let's deploy our Forge app, let's install our Forge app, and yep, this is a Forge app. It doesn't do much, of course, but it's a perfectly valid Forge application. And what actually happened here is we installed our application has static resources, we downloaded the static resources, we show them in the browser, and we see our waving hand. Now what we want to do next, quite obviously, is we actually want to load some meaningful data, right? So we need to think about how can we call our own endpoints, or arguably even more importantly, the Atlassian endpoints. And luckily, Atlassian gives us all the tools that we need for that. So we have a very, very rich, a very comprehensive REST API that allows us to do pretty much anything that we want. We have a so-called Forge bridge, which is a library that allows us to call these endpoints from our front-end application. And we have the Atlassian design system with its component library called AtlasKit, right, that contains everything from buttons to selects and dabs and whatnot. The thing is, what we found is that these building blocks are all relatively unopinionated on how they are used. And that kind of makes sense, right? Because there's a million ways of writing code, and these building blocks should work with as many of them as possible. So in order to write your own Forge app, you need to do a little bit of stitching to bring them back together. Again, is it rocket science? Absolutely no. Could it take you a couple of days to set it up? Yes, probably. So what we did is we took a close look at our own code base, and we figured, well, actually, there is a very, very solid framework that we built, solid foundations that we built our app on top of, and that framework actually brings together all of these building blocks for you already. So we thought, well, couldn't we extract that framework from our app and make that available to everyone? And that's exactly what we did. So what I would like to do today is introduce the Forge Dev Kit, which is a zero-config toolkit for building fine Forge apps. It's available for free. It's open source, so try it out. But first of all, let's look into it. Let's understand what that actually is. So in order to use the Forge Dev Kit, what we're doing is we're invoking a simple CLI, and that CLI creates a pre-configured Forge module for us. That Forge module is based on TypeScript, React, Emotion for styling, and Next.js as an application framework. And these are all, why did we pick these particular frameworks? Well, on the one hand, they're just really good. And on the other hand, they are very mature and very well documented. So even if you're not familiar with one of these frameworks at the moment, it will be very, very easy to kind of become an expert in them. What FDK also does is it brings in the Atlassian design system and its component library, AtlasKit. So you can just use these components. You don't have to configure anything, don't have to worry about bundling, etc. It just works. And last but not least, it includes a number of libraries that we developed ourselves that make it very, very easy to consume Forge capabilities from TypeScript, from React, from the technology stack that we're using. It's so simple, in fact, that we're going to use the rest of this time to build a Forge app. Shall we do that? Shall we? Oh, I think we shall. Let's imagine we have a couple of teams in our company that really care about attachments. Could be a HR team, could be a legal team, and these folks really love the file browser from Slack. So maybe we should try bringing that into Jira. Is that too big for 15 minutes? Let's find out. So what we're going to do is we're going to invoke our Forge Dev Kit CLI and create our module. And this module, don't worry about all the files, we'll get into that, is best created besides your Forge app. So we already have a Forge app, we created it via the Forge CLI, and besides that Forge app, we're creating our Forge Dev Kit module. Before we get into the module, we need to make a couple of adaptations to the app descriptor, to the manifest. And what we're doing is we're changing this Jira project page that we had before, give it a meaningful name, let's call it attachments, and redirect the path to the static resources to our new Forge module. Now, we also need to add a few more configurations, but don't worry about it, that's all documented. Now let's look into the Forge dev kit module. There's a couple of files in there, yeah, but we really only have to worry about source index. All the other configuration files, you can dig into them if you want to, if you feel you have to, but you shouldn't have to. We really worry about the index file, and what we see here is looks familiar. It's our waving hand from before. It's now written in React, but it still doesn't do much, right? So let's see if it works. We start our development server, we start the Forge tunnel, which means that we see our changes pretty much in real time. We switch back to Jira, and well, yep, it does seem to work. It doesn't do much, it's still just a waving hand that is now written in React, but it works. So let's do something meaningful, shall we? The first thing that we need to do is we need to understand where are we, right? Where is our code actually running? What's the context of our code? What we can do now is we import from one of the libraries a function called useProjectContext. If you're familiar with React, that's a hook, but that isn't even important. What is important is this function, when invoked, gives you a so-called project context. And that project context contains a number of values, one of them being the project key, which, as you can see, we're now adding to our little headline. So if we switch back to Jira, we now see, yep, we are running in the demo project. Okay, still not overly useful, but you can see we're already showing dynamic data, right? It already makes a difference where that code is being run. So what we can do next is we want to get our attachments from within the demo project. Unfortunately, Jira doesn't give us an API that lets us grab the attachments directly, so we need to take a bit of a reroute through our favorite Jira entity, namely the issue. So what we're doing now is we're importing another function called useIssues. And useIssues is essentially a wrapper around the search issues functionality of Jira. Because we are all fully typed and using TypeScript, we get code completion, and we immediately see that we need to provide a JQL statement. Not gonna go too deep into that, but we're basically loading all the issues from our current project that have an attachment. We also need to tell Jira which fields we're interested in. We're interested in the summary, we're interested in any attachment. And because we're actually doing a REST call now, that data is by definition asynchronous. So we need to wait a little bit until that variable actually has a value. So what we want to do first is, in line 11, we want to make sure that as long as we don't have a value yet, we show some simple loading indicator. And once we do have the value, we're iterating over our issues and rendering some HTML. Let's see how that looks. Right, what is that? We now see a list of issues that have attachments. That's a step further, but not quite what we're looking for. So what we want to do now is we need to do a little bit of data manipulation and extract attachments from our issues. So there's this code. Don't judge me too hard on my code. I just wanted to keep it simple. But what it basically does is it iterates over the issues and extracts the attachments from the issues. And now we can iterate over these attachments and generate some HTML. Now, how does that look like? Oh, yeah, right. That's basically a file browser, right? We're seeing all our attachments along with the issue where the attachment is coming from. It's not exactly pretty, so let's look into that. So what we're going to do next is we're going to extract the piece of code that renders the individual attachment into an attachment card. So what I did is I created a second file. I'm importing the attachment card component, and down there I'm rendering the attachment card component now. And within our attachment card, we can go wild on the styling. I'm going to fast forward here a little bit, but you can see there's a fair bit of markup. There's a fair bit of CSS going on, but it's standard React, right? There's nothing special there. If we look into one of these CSS definitions, You can see we are setting the border. We're doing a bit of spacing. We're actually using color constants that we're importing from the Atlassian design system, and that just works, right? We don't have to configure anything. That just works. And even with all that styling, we're still only at, 44 lines of code. And I think in the other file we had 30 lines of code, so it's not a lot of code, right? So let's have a look on how this actually looks in action. We switch back to Jira. Well, that's pretty close to our Slack file browser, right? Let's compare. Yeah. I mean, there's still a couple of things missing, right? Would we want to show a file icon? Yep, totally. Would we want to show a little avatar next to the usernames? Yep, we would want to do that. The thing is, we already have all of that data in our app. We just need to translate it into some HTML, but that's not hard, right? If we take another 30 minutes together, we can easily do that. And the other thing is, this thing is now running on Forge. That's an actual app, and it's probably going to run there for the next 10 years, right? Because we don't need to take care of the operations. That's done by Atlassian. We deployed it into the Atlassian cloud, and that's where it's going to stay. So let's take a step back and do a little recap of what we actually did. What we did now is we created an app, we downloaded it into the browser, and as our app is being executed by the browser, we're making calls to the various endpoints. In our concrete example, we're actually only doing calls to Jira, and you'd be surprised how much you can do with the standard Jira APIs, right? They are incredibly powerful. I rarely ever feel the need to create my own API endpoints. But if we would want to, we could easily do that. Now, how did we create that front-end application? We used the Forge development kit, which gives us which takes away all that configuration and setup requirements. We can hit the ground running and start working on features right away. And again, this is 75 lines of code, and this includes a couple of empty lines. I mean, that's legitimately amazing, right? That's unheard of. Building your own app in 75 lines of code, an app like that could already be incredibly useful to your teams, right? I mean, depending on the use case, that could save your team hours of work every week. But also keep in mind, this is really, really not the limit. We extracted the Forge development kit from JXL, which is one of the fastest growing apps in the marketplace and used by some incredible companies. So I strongly encourage you to try out Forge, try out the Forge development kit, play around with it, think about how you can create the perfect Jira for your teams. And I'm pretty sure you will love it. And that brings me to the end. Thank you very much.